Okay, so we are continuing with Chapter 9, Stress, Force, Area Calculations. You will remember these triangles here. These are just my tools that I share with you. You can use these to help remember the formulas. So when you're juggling all the variables, nothing gets too, pardon the pun, too stressful. Anyway, the thing is that there's two triangles down here because we have metric system and imperial system calculations. And unfortunately and fortunately, in the realm of construction, we have both of those systems because we inherit those systems historically from different countries. So that's about it. And we're going to continue. I think we left off at question 5. We finished 5. So this is my notes from last time with you. So here's the next one, number 6. I'll keep those triangles on the side here and just give them a little bit of a zoom. So just read that question while I'm doing some housekeeping here. Cleaning up my pretty slides. There we go. And I'll give that a zoom. There we go. Okay. So we have a tube made of aluminum and it's hollow. See the hollowness here? The hole there. And therefore, because it's hollow and we assume it's circular, as mentioned here, there's a diameter on the inside and the outside. So you know it's a circle. So in the cross section, we need to calculate the stress in this tube. And then we also need to do some stuff regarding the material. So just read the question for another 20 seconds or so, and we'll start. Okay, so the material is aluminum. But for the first part of the question, I don't care what the material is. You don't care what material it is because stress, force, and area, this equation here on the side, is insensitive to what the material is. It's just a straightforward calculation involving stress. So, stress equals force over area. So I'm going to this is part A, and I'll label it later part A. This calculation here is a matter of just dividing two things. Now, take a look here. We have a force. Ooh, 52 kilonewtons. I don't like that. So I'm going to stop at that point. And this is kind of how I do things. I'll come back here and maybe we'll clean up the variables first. So, because these quantities are not in the most orthodox of units. Let me know in the chat. Is this question metric or imperial? Let me know. Metric or imperial? Anybody in the chat there? Metric, thank you. So we don't want kilonewtons. Kn is no good, that's kilo, but we can write it as newtons by replacing the K with 1000. So that fixes that issue. The area is not an issue, it's just a lot of work. See, the area here is a hollow, the cross-sectional area is a hollow shape. So it's the subtraction of two circles. So it's pi r squared. But in this case, we got to put a outer radius and then pi r squared, but with the inner radius. So you're taking away the big circle on the outside minus the little circle on the inside. Now, for the sake of writing this, I'm just going to write down the numbers, but then I have done these calculations earlier in my notes. So we have here the outer radius, which is actually 24 millimeters. Now, some people are going to question, why is it 24? I'll discuss that in a second, or maybe in the chat. Can someone let the classmates know? Let their classmates know why it's not 48. Why is it 24? What the heck happened there? Someone let the people know in the chat. Share your knowledge. Thank you, Amira. It's a radius. Yeah, these are radii. See, these are diameters because of the radius. Thank you, Ram. Because these are diameters, but we have radii. Of course, feel free. You can use the area of a circle in terms of its diameter. If you don't know the formula for the area of a circle diameter, it goes pi d squared over 4. That's the formula for the diameter, width through the diameter to find the area, but we're not using that formula here. I did it two different ways last time anyway. So we got the area out of the way, which is good news. I did this calculation earlier, so just take it for as a fact that it's okay. I have scrutinized these numbers before in previous semesters from my personal notes, so I feel very confident about them. So anyway, The good news here now is we have newtons and millimeters squared. Let's take a look on the side here. See, we have newtons and millimeters squared. That's good news, meaning that we are in the most orthodox of units, the ones that we want to have, and they will produce a stress value of in magnitude of 47.1, and the units are megapascals. And this is a discussion from last lesson. We know it's megapascals because of the consistency between newtons per millimeter squared being equal to 1 million pascals, or 1 megapascal. So this represents part A of the question. I'm going to scroll down because we don't need the words and the text anymore there, and we already did part A, so I'm just going to go there because that's all you really need to finish now. This is part A. Write that in lowercase. I'm not trying to yell at anybody here with my typing. Okay. Anyway, part B. Part B says what percent is the stress occurring of the ultimate stress? So now we need to consider the material behavior. So I'm going to go here and say that the stress, sigma ultimate, material is aluminum. So the ultimate stress of aluminum is 140 megapascal. If you're wondering where did I pull this number out of, remember that on Friday we did this table, we exercised some practice here in the table. Yeah, so for today's class, everybody, I'm going to just not look at the table and tell you how I found the number. If you're worried about that, you do have an assignment this week that requires you to use the table. So you'll figure it out from there anyway. But we did talk about it, and if you go to the previous lessons recording, which is available, of course, on Blackboard and YouTube, you can definitely look it up there. So anyway, we got our thing there. We got our ultimate stress for aluminum. Hey, look, this is like calculating a score, like a percentage, like you would calculate your test score. Hopefully nobody gets this mark on their test, because that would really not be good. But for design considerations, you don't want this percentage to be too high, because then if it's too high of a percentage, it's not safe. So to two significant digits, I have it here to the nearest percent. It's 34%. We can start discussing things like factors of safety. So this thing here has a factor of safety of 3. See, the way that you can calculate factor of safety is basically the reciprocal of this. If you did 1 divided by this number, that's the factor of safety. I will discuss factor of safety as a formula in subsequent questions. So we'll leave that brief discussion aside for a second. Okay, so that's enough of that tube. Oops, let me go back for a second. Just let me know in the chat when you're ready to move on, or if anybody needs more time, please let me know. Okay, is that a yeah to move on, or is that a yeah to wait? Okay. Who needs more time on this question? Just tell me wait. Okie dokie, I got a couple of go-aheads. There's 17 people, including me here, so I'm hoping I hear more people tell me to move on. I just want to hear a few more people be clear that we can move on. This was a long question. Okay, let's move on. Number 7. This is a unit conversion question. So I think that on your test, there is one question that has unit conversions, but it's not too dangerous. So I won't say it's as easy as this one, but it's comparable because it's just arbitrary units here of tons per square foot, and we want to convert to PSI. So the question is, do you remember what a PSI is? What does 1 PSI mean? What does 1 PSI mean? What does it stand for? 1 what? Anybody in the chat there? Okay, PSI, literally, if you write it out in English, is 1 pound per square inch. Okay, So that's what PSI stands for. So in this case, we say it's 1 lb or pound per square inch. It's okay. It's good that you're being honest there, because then I can help you and adjust my my pace. So we need to convert, ultimately we need to convert the tons and the feet squared into pounds and inches squared. So the author here says direct substitution. We could try that here. I'm not really a fan of direct substitution all the time, but it does work here, so we're not going to fight it. We have that in the question. Now, I'm going to rewrite it a little bit differently. I'm going to write it as a fraction like this, 56.4 tons. Now, you can put plural there. You're not going to get in trouble either way with me. But we need to convert tons into pounds, and we need to convert square feet into square inches. And when the author says direct substitution, they literally mean substitute the unit for something else. So here you could do a ton is worth 2,000 pounds. By the way, you should know that for your test. And also a foot is 12 inches, which I'm sure I've seen enough times on my assignments. So there you go. That's the answer, okay? So you got to do 56.4 times 2,000, but then you got to divide by 12 squared. You got to divide by 144. And if you do all that work, you're going to get, let's see here, I got 783 pound per square inch, which answers the question. I could write PSI there, but I'm running out of space on the side, so we'll leave it like that. So there you have it. Okay, are we clear to move on to the next one? All right. Thank you. So I was just browsing through the sheets there, the slides I mean. The next three questions involve wires and talking about what is the safe diameter or the minimum diameter to support a weight. In the first case, we want to support a 185 pound or weight object. In the second example, we want to do this with a steel wire of a mass of 1,100 kilograms. So we can play with these questions very well. I think that if we do both of them, it can only enhance your understanding, so we will do both of them. I'll do 8, and then I'll do 10. I think I'll do 8 and 10 because 10 has a factor of safety. So this way we do one metric, one imperial. And then the 9 that we skip, we can do it on Friday. So this way we can get like variety today, and we can have reinforcement on Friday. Anyway, we should be able to hammer these next two ones out in the next, hopefully in the next 20 minutes. They're not short questions. We'll go slow. They're not long questions either. They just require details. What is the minimum safe diameter that a wire can have if the tensile stress developed in the wire must not exceed 6,200 psi? So there's a load here of a supported mass of 185 pounds. So let's put together the story here. Now it's talking about safe diameter. So when a question says diameter, when the question says diameter, I'm going to write the word minimum here because that's actually important to the question. When the question says minimum diameter, the clue for you is that you need to solve for the area first. That's the hint, okay? That's the secret sauce there. You got to find the area first. So if we go from the stress formula thing, the triangle, let's go over here and find that formula triangle. Where are you? Where are you, buddy? There you are. Area is force over stress. So we know that area is equal to force over stress. Thank you very much. Yeah, so Amir, I took your version and I scrambled it the other way because we want to get the area. So yes, that's good though. What Amir wrote in the chat was the original formula, which was here, and I've rearranged it for what we need. So the first thing I'll do is I'll write down the load, which is 185 pounds. And then the stress is also given, which is kind of nice. It's very friendly there, 6,200 psi. These units, as you can see, are the most orthodox of units for the imperial system calculations. You see on the side here we have PSI and pounds per square inch. So this is right exactly where you want to be in terms of calculations. So it looks like we can just get the area now. It looks like we're good to go here. So 6,200 PSI over 185 pounds. And I'm going to give it lots of digits here. I'm going to go with a lot of digits here. We'll put 0.02984 square inches. Now, the reason that we know the answers in square inches for the cross-sectional area of the wire is because of the consistency between PSI, pounds, and square inches. So the next part, of course, is an assumption. We assume that the wire is circular in cross-section. We're assuming the wire is a circle when you take cross-section, okay? Like, don't think that the wire is a rectangle. And if you're not sure about how you know, well, how do you know it's a circle or whatever, when you see the word diameter in a question, it really limits the possibilities of cross-sectional shape. Yeah, the P is, oh shoot, did I have it backwards? Yeah, I have it backwards. I'm so sorry. Sorry, let me correct that. Take it easy, Feng. I guess I can't type and talk at the same time. I have to go on silent mode when I'm typing. Yeah, it didn't make sense actually because the fraction's so small. It should be like 3%. I was looking at it now. That's kind of silly. Okay. Hopefully you forgive me. Hopefully you forgive me. So let's switch over and do some algebra now, because so far it's been looking pretty bland. We're just plugging stuff in. I want to do some mathematics involving algebraic manipulation. 2,984. Sorry about that. Just had to clear my throat for a second. So we have pi r squared equals. I want to center this so it looks a little bit easier to read. There we go. So now we're just switching over and talking about radius calculation. So be careful here because we need to consider some extra details at the end. I don't suspect that people have too much of a challenge solving this, but I'm not taking it for granted. Before we solve it though, I want to introduce a subscript here. I want you to write the subscript min, because we're trying to find the minimum diameter. So this subscript is very important in terms of communication. If you don't write it, you're not going to lose any grade for it, but it's important to me. And also, you could write inches squared here on the right. You could write inches squared, but I'm being a little bit like, not lazy, but just not, I don't want to clutter it right now. So anyway, the minimum radius, go through this slowly because I do have a feeling some people are gonna need a little bit support here. But I don't have my calculator in front of me, so can someone please do that calculation? Give me like 4 significant digits, if not more. Can someone do that calculation? 0.2984 divided by pi on their calculator. Thank you, Ram. Can you give me a little bit extra? It's okay. Like 9.5 or 9 what? A little bit more? 9.498. Thank you. Okay, so we have the minimum radius squared, and now you would square root that. Now, in this example, I'm taking baby steps, but in the future example, I might do less work, just so be aware of that. It's okay to do these steps here because I know some people will appreciate this here. So anyway, after a lot of sweat, we end up getting, what do you get here? 0.0, I'm guessing like 97. What is it? Can someone give me a number there, please? 97, 98. I'm trying to do it in my head. It's not working. 9745. Thank you. 6. Which one do I pick? Rams or Zfangs? I'll put the 6. Forget it. It doesn't really matter. Let's do this. Let's put 975. They round the same way. Okay, that's compromise, my friends. All right. So that's the radius. The question wants the minimum diameter. So you should know to multiply by 2 there. And here's the fun part. Here's the fun part. We want the minimum diameter. So we're going to multiply that by 2. When you multiply that by 2 on your calculator, what do you get? 195 inches. Someone confirm that they have this at the end? Awesome. Okay, so why was the whole big deal about writing the word the subscript min? If you don't write the min here, I'm not gonna like lose. You're not gonna lose any marks. I just want to mention one thing here. Whenever you find a min value, a min threshold, if you want, you should always round up. So that's not really easy to explain on this example because I didn't really keep a lot of digits in terms of showing you the steps. I have lots of digits here, but we don't actually see what happened with this number here. But I assure you that if you get a number, like for example, if it was 0.1941 or 0.1942 or 0.1943, etc., all of these numbers on your calculator screen, even though the first 3 numbers here that I've written, they would round to 0.194 under just regular rounding rules. When you're talking about a minimum quantity, you want to round up. So all of these would go to 195 because it's like the analogy I gave last week of like paying for the bus or something. You have to round up if you don't have exact change. So that was a pretty gross one, 9.8 there. But I think that we can move on now to the number 10. I said I would skip number 9, but I can actually, yeah, we're gonna skip 9 and do it on Friday. So let's do number 10. Let's do number 10. Just let me know in the chat when you're ready to move on to the next question. So let me know in that chat that you're good to go. I want to hear from at least 6 people. I got 3 so far. That's 5. One more person. I don't count as one person. So it's got to be someone in the crowd. One more person, give me clearance. Okay. This is painful. All right, Tommaso, thank you. All right. Okay, so here we go. We're skipping 9, but we will do it on Friday. Number 10. What is the minimum? Okay, so you see it's kind of the same thing here. It's a copper wire. And there's 2 differences in this question. One, it's in the metric system, which is not that big of a deal. And 2, there is a factor of safety. So let's figure out how this compares to the previous one. Like, I feel compelled to do what I did here. I'm gonna take this answer. I'm gonna take all this answer here. Watch that. I'm gonna take that and just drop it in here. And let's see how this fares. Okay. So, excuse me. I'll edit out this whole deleting stuff, and after I finish with you guys today, I'll clean up all this stuff, and so that you don't watch me deleting all this crap on the recording later. So you see how there's a template now? If you want, you can take a screenshot of this, or when you watch the video later, you can take a screenshot later. But this is basically your template for figuring out what to do with wires. when you have a wire and you know the force or load that it has to maintain. And in this case, the stress is not explicitly given. In the previous question, the stress was given to you nicely, you know, with a nice bow on it. It was easy. In this one, you got to do a little bit of extra labor. So firstly, let's get that force. So we have 390 kilograms. Now, I noticed on your assignments, number 10, most people on the mass and the weight questions, they got them right. But you notice that some people I deducted like 0.1. Even though the answer was technically correct, you didn't do it in the most efficient way, which is to, like, if the question's in pounds, why are you changing it to newtons? You don't need to do that stuff. Anyway, in this, I will never ask you on the test to convert from metric to imperial for this this stress force area calculation stuff. So please keep it in the same unit system. Anyway, but for those people that did it that way, it was exceptionally good that you remembered the 9.81. So 9.81 meters per second squared. You can also put their newtons per kilogram. You could also do this, for example. This is a legit unit. You could do newtons per kilogram, but I'll leave it as meters per second squared because that's the way that I've been talking to you about it. Anyway, so that's the one thing about the metric system is all the units are kind of separate so that you can keep track. Force and mass are distinct in terms of their quantity, so you don't get them confused. But anyway, there's the newtons. The stress, we got a little bit of an issue. This is new. This is new, so I'm going to do this in like some fancy bold color here. Let's use green. So this step here, we've never done it before. So get ready for it. This is the last piece of the puzzle in terms of math for this chapter that I have not discussed with you. You got to go back here, and I'll tell you the page number once I get there eventually. Okay, here it is. Page 12. Okay, page 12. See that formula? I'm gonna take a screenshot of it, and I'll reference it once I get back to the question. Just a second, people. I'm on 3 screens. I feel like I'm a concert pianist. Okay, trying to manage all these buttons. So anyway, that formula there is on page 12. So I didn't pull out of thin air. I'll just write down page 12 here so that you don't think I'm making up stuff here. Chapter 9, page 12, okay? You're responsible for that formula, and between the formula that I have in purple here, which is kind of like your guideline for everything, you can also introduce this into the mix. So we can say here that the factor of safety is 5. So we have here 5. So we're going to have the ultimate stress. What's the material? It's a rhetorical question. I'm just reading the question to myself as well. Thank you, copper. And the factor of safety, or is in this case 5. Now, if you don't mind, I'm going to cheat because I did this earlier. I got 340 megapascals. I think we had that one in a previous question. So 340 divided by 5. Many of you should do that in your head. Hopefully there's a few people in this crowd that can do that in their head. Anyway, there you go. So we have all the goods. We have 3826 newtons over 68 megapascal. So from this point henceforth, the question becomes like the other question, except instead of having square inches, you're going to have square millimeters. But the routine is the same. Okay, now I'm going to take this, just delete this. I will copy it in a second, but I'm going to use my solution here because I can just copy and paste it from my solution. A little bit more efficient this time instead of writing it out. And I did do all the steps in the solution, which is the reason that I'm showing it with you here. Okay, so that looks a little bit crusty. So let's just do this. Let's crop that out. So bear with me for a second here. So there you have it. I'll give you 2 minutes. I'll give you 2 minutes to digest it, get down all the stuff that you need to get down. and we'll reconvene in 2 minutes. Okay, so I just wanted to give you a moment to digest that. A couple of comments from the chat there. That number came from the table. I've color-coded it in green here so that you can reference it back to the table as you review these questions later. So it's we got about 10 or 11 minutes left. So I feel like we should do one more question. I think one more question should be good, and then after that you can go on your way and enjoy your afternoon. And then on Friday we will continue. We can hammer out another 5 or 6 questions. We'll see how Friday goes. We might finish early. It looks like because we took a nice aggressive first step last week and got ourselves really involved in the chapter. Well, I don't think we're going to be too dangerous in terms of running out of time. So, question 11. So this will be our last example today. I had to just zoom out for a second, if you don't mind. Maybe I can do a little bit better than that. So just read that question for a second as I look back for my triangles. So we saw a question involving a cylindrical column in the previous lecture, and remember that I mentioned something about buckling. So buckling is when the column will make like an S shape and fail that way. That's when you have a really high aspect ratio, slender type object. We're not really too concerned about buckling, so for that reason, I'm going to just say that this number here, we don't care about it. We don't care about the height of the column, assuming that the column's aspect ratio is sufficient enough, and other factors as well, like the load itself, to not have buckling occur first. So in this case, we want to find out the maximum force or load that the object here can sustain, or withstand, I should say. And that's it. And it also says, oh, tons. Don't forget, there's a little bit of cosmetic stuff at the end, a little unit conversion at the end. So once we get the answer, which will be in pounds, don't forget to do that silly last step, which is to write it in terms of imperial tons. Find the stress. No, sorry, we're trying to find here the force. So going by the formula, we know the force is equal to the stress times the area. We know that's our formula that we're playing with. So the first thing we're going to do is write down the force and, sorry, the stress in the area. You know, if you're writing a test and you don't know which formula to use, in all honesty, you could just do this. This is not how I'm going to answer this question. You could just do that, eh? If you don't, let me just write it this way, because I want you to get a feel for what I'm trying to say. So like here, like if you're like, I don't know which one I'm solving for, write all three down. Just write all three down like a checklist. So the stress is given because it's 550 psi. That's a stress quantity. The area is given. I'll put a happy face there because we're going to deal with it in a second, but it is obtainable. And this is the one we're solving for. So you can see that you could write a list of how to do things. What shape is this cross section? What shape is the area based on? Is it a rectangle? Is it a vertical cross section? What is the cross section that we want to find the area for? What shape? Anybody? Yeah, it's a circle. I'm not trying to trick anybody here. It's a circle, okay? You're just when I talk about the area in terms of the force, see this force here is acting vertically, and it acts at 90 degrees like that. That's a right angle to the surface, which is the cross section. So if you imagine like a slice, that circle there is the cross-sectional area. And that circle, it goes continuously through the material, like layers, like a pancake. Don't make me hungry though. We're still in the brunch lunch area of time for me. Anyway, so pi r squared. So the radius, ooh, that's not good. Okay, so we gotta do a little bit extra work on the side here. Little bit of extra work here. We're given the diameter is 3 feet 5 inches. So the diameter is, what is that, 41 inches? Confirm? Someone confirm? I'm not looking at my answers here. I'm just kind of winging it right now. Someone confirm those numbers. Thank you, Jifeng. So I converted that to a radius because we want to use this version of the area of a circle formula. So go back here now, and that's pi times 20.5 squared. Not that I'm trying to sell you videos, but I have a video to show people how to do this in their head. I made a video about that if anybody's curious how you do that in your head. But I won't discuss that here. But if you're curious how to do that, stick around at the end of class. Anyway, pi times 20.5 squared, approximately 1,320. In this case, it's square inches. So we're good to go at this point. We have our stress, which is 550 psi. We have our area, which is approximately 1320 square inches. Perhaps I can just write this a little bit nicer. Okay, that gives us a value of roughly 726,000 pounds. Any comments? Are we done the question? Can I dismiss you? Are we good to go? No. Damn it. What's the problem? Why are we not finished? I was so excited to escape. I was so excited to escape the lesson. Yeah, tons, exactly. So you need to know a conversion here. Actually, don't worry. I'm the last person that wants to leave a lesson. I'm actually having fun doing this. Anyway, 1 ton equals 2,000 pounds. Don't forget that. You need that for your test, okay? I'm pretty sure that it pops up somewhere. So that over here, that's an easy fix. So just divide by 2,000. I'm not going to show the actual operation. No. You don't have to show those calculations. No, that's Janvi, that's the metric ton. Janvi, that's the metric ton. This is imperial tons. Hold that thought for a second, okay? Hold your thought on that for a second. I'll get to that in 1 second. It's a very good comment. It's a very good comment. Let me just deal with this for a second. 363 ton. Now, so what Janvi's saying is this. I'll just mention it here. 1 ton is 2,000 pounds. And then here, we're done the question, by the way. Let me just highlight that, bold it up, make it pretty. Let's use a blue. This question's done now, okay? Put a bow on it, it's finished. This is just extra discussion based on a question in the chat. 1 ton is 2,000 pounds. 1 TONNE, that's metric ton, is 1,000 kilograms. Pounds to kilograms, there's 2.205 kilograms in a ton. Sorry, there's 2.205 pounds in a kilogram. I just have to write it down. I can't say it. Sorry, 2.205 pounds. That's the conversion, okay? So there's a slight difference between the two. They're not made the same. So cool. So this is a very fun question. This question's not on your test, but in past exams I've asked this: which is bigger? This is not on your test, okay? This statement here, this one question I'm telling you, is not on your test, but I'm not saying that anything else isn't. Okay, which is greater? A ton or a ton? I asked this on a test a couple years ago, on the final test, and I had a few people put their hand up, and they're like, I don't know the difference, sir. And I'm like, geez, I don't know. Because for those that have been to class, which you all have been, I see all the time here in the chat. You know, that's something that I bring up in class at least 3 or 4 times in this unit and in the past unit. So might as well settle that here. What's the answer? What's the answer to this old test question? I mean, it's pretty clear. It's a ton. Yep. And the funny thing is, as a student back in the day when I was doing my engineering stuff many, many years ago, The easiest way to remember it, this is very childish, but it works. Which is the bigger word? This has more letters in it, so it's bigger. I know that's very childish, and don't laugh at me, but it works. Just remember the one that has the more letters in it is worth more. I'll never forget it that way. Anyway, that's enough for today. I hope you have a lovely next few days, and I will see you on Friday, 10 a.m. sharp. And for those that just arrived, maybe later, see you then. Just remember that the test information is available on Blackboard now. So yeah, you can see what the test breakdown is, and that'll help you organize yourself and study. Thanks, everybody. Have a lovely day.